Hello, today we are doing 2.5. We're going to do this in 2 days. Today's day 1, graphing rational functions. Our essential question is, what are some of the characteristics of the graph of a rational function? Sure, right about now you're asking yourselves, gosh, what is a rational function? I'm glad you asked. Here is the parent function of a rational function. You might want to hit pause and write some of this down. I'll tell you right now, 1 over x, that's your parent function. You're going to have a horizontal asymptote along the x-axis at y equals 0, and you're going to have a vertical asymptote along the y-axis at x equals 0. Those are going to be really important to remember. Remember, an asymptote, it gets really close, but it does not touch. So what we're going to be doing is we're going to be shifting that parent function around some. So we might have something like a, which will be some constant, over x minus h plus k. What we need to do is we need to figure out h and k. H is whatever is being subtracted from x. K is whatever is being added at the end. We're going to have asymptotes at x equals h, that'll be vertical, and at y equals k, that'll be horizontal. And then typically we're going to plot some points to the left and right of the vertical asymptote. That kind of gives you a little bit of a guideline, and then you're going to draw 2 branches, and they should be kind of symmetrical of each other. Okay? Let's go ahead and get one done. So we've got g of x equals -4, x plus 2 minus 1. Well, that negative sign right away tells me I'm probably going to have a reflection. The plus 2 is the same as x minus -2. So I'm thinking that this is going to be shifted to the left 2, and I've got a -1, so it's going to be shifted down 1. So I also am going to have to state the domain in the range. So let's go ahead and draw those asymptotes. It's going to be at x equals -2, which is my vertical line, and at y equals -1. And we want to choose a couple points to the left and to the right of our vertical asymptote. Those are points that you choose. So if you're kind of a visual person, what you might even want to do is make a quick little t-table, and you know your vertical asymptote is at x equals -2, and do this in a different color so you can kind of see. What they did was they chose some numbers that were smaller, -3, -4, -6, and again, those are numbers that you choose. And then they chose some numbers that are bigger, -1, 0, and 2. You plug those back in, and that gives you your y values. I'm not going to do that because you guys are in pre-calc. I'm going to assume you can do the plug and chug of it. So we drew our asymptotes. We plugged in some points, plotted them, sketched it out, and then we drew it. You should have something that looks like this. You can always check yourself on Desmos. However, you're not going to be able to use that on a test or quiz. Your domain is going to be all in the real numbers except x cannot equal -2, because that's where you have your asymptote. And your range is all real numbers except -1, because that is where you have your horizontal asymptote. What I suggest you do is hit pause. Try these 3 on your own. When you think you have them, hit the play button and check your answers. Here you have a vertical asymptote at x equals 0, horizontal at -2, at y equals -2. On this one, if you wanted to, you can think of it as plus 0 at the end. That's why you're going to have a horizontal at y equals 0. Your vertical is at -4, x equals -4. On number 4, your vertical is at x equals 1, and your horizontal is at y equals 5. All right, what are we going to do if it's not in that form? We have f of x equals 2x plus 1 over x minus 3. Well, we know that our domain cannot be x equals to 3 because we're not allowed to have a 0 in that denominator. So that gives us our vertical asymptote at x equals 3. So we've got that right now. The horizontal one is a little bit trickier. What you do is you look at your highest exponents here, the x's. You have 2x over x. If I were to reduce that, I would end up with 2 over 1, which is 2. And that is where my horizontal asymptote is coming from, at 2. If for some reason I've got a higher power on top, I'm not going to have a horizontal asymptote. Okay? So just kind of think of that as 2 over 1, and that gives you your horizontal asymptote. Then you plot the points just like you would before. You know where that vertical asymptote is. It's at 3. Choose a couple numbers smaller and a couple numbers larger. On this one, we're going to want to rewrite 3x plus 5 all over x plus 1 in the form of a over x minus h plus k, and then we're going to graph that function. This sounds difficult, but it's actually pretty straightforward. We're just going to use division. And actually long division, I think, is the easiest one on here. We're going to put x plus 1 on the outside. 3x plus 5 goes on the inside. You're going to ask yourself, x times what gives me 3x? Well, the answer is 3. Distribute. 3 times x gives me 3x. 3 times 1 gives me 3. So then my remainder is going to be 2 over x plus 1. However, go ahead and write that right now. Your remainder is 2 over x plus 1. We rewrite it as 2 over x plus 1 plus 3. Write the remainder first to get it into that form. Our vertical asymptote is going to be at x equals -1. And our horizontal is at 3. Which we could have gotten just looking at here, but it would have been in the correct form. We could have looked at our denominator and said, well, x can't equal -1, so that's going to give us our vertical. 3x over x is the same as 3 over 1. That's going to give us our horizontal. What I would suggest is hit pause, try these 3 on your own. When you are ready, hit play and check your answers. Yep. Here, you're going to have a vertical at x equals -3, because you can't have 0 in the denominator. Think of that as 1 over 1. That's going to give us our horizontal. Here, 4x minus 2, set that equal to 0, and you're going to get x equals 1/2, which is our vertical. 2 over 4 is also 1/2, which is going to give us our horizontal. So our vertical is at 1/2, our horizontal is at 1/2. Here, take that negative x minus 1, set it equal to 0, and you get x equals 1. I'm sorry. And then you're going to have your horizontal. You're going to have to get negative 1, and you're going to get your horizontal. I'm sorry, vertical. Done too many of these videos. I was already starting to think ahead of the horizontal. The sideways one. Negative 3x over negative x reduces down to 3. Y equals 3. All right, we're going to go on to the next example. We've got a 3D printer, builds up layers of material to make a three-dimensional model. Each deposited layer bonds to the layer below it. The company decides to make a small display model of engine components using a 3D printer. The printer costs $1,000. The material for each model costs $50. Estimate how many models must be printed for the average cost to fall to $90. So let's go ahead and understand that problem. You're given the cost of a printer and the cost to create a model using the printer, and then we're asked to find the number of models for which the average cost falls to $90. Well, our plan. We want to write an equation that represents the average cost, and we're probably going to have to use a graphing calculator or Desmos. So let's go ahead and solve that problem. We're going to let C be the average cost and M be the number of models printed. So the unit cost by the number printed plus the cost of the printer divided by the number printed. That's going to give us our average. It has to equal 50M plus 1,000 over M. If you use the TI 83 or 84, use the trace feature. If you use Desmos, you can just pretty much click on it to figure out those ordered pairs. And what you find out as the average cost approaches $50, more models are printed. All right, that's all I have for today. Tomorrow we start solving some of these guys. And that last example would be a better one for probably tomorrow. Until then, enjoy.